Continuing on with session 2 of our TSI math prep. This session will be going over factoring, quadratic equations, and line of symmetry. And here's some additional resources. So the first thing you do is factoring, for factor completely. When we're talking about factoring, what it involves a quadratic equation. Now what we know about a quadratic equation is the standard form is ax squared plus bx plus c. What we need to do is we need to factor into two binomials, just like those answer choices below. So in doing that, what we need to do is we have to do basically reverse foiling. That's one of the first methods you'll learn when you're factoring. So to do this, what we know is we have two sets of parentheses, and we know it's x and x because from the foiling, the first terms, x times x gets us x squared. So now we think about what are two numbers or two factors that multiply to get you negative 21, but add up to get you 4. So you can do is you can find factors of 21 and write on the side here. 121 and 3 and 7. So obviously the only pair we can use is 3 and 7. 3 here, 7 here. And now we need them to multiply to get you a negative 21. So in order to multiply to get you negative, only way you can have that is you have one positive, one negative, but they need to add up to get you 4. So only for that to happen is you have a minus 3 and a positive 7. So the factor form of x squared plus 4x minus 21 is x minus 3 times x plus 7. So our answer should be B, x plus 7 times x minus 3. It doesn't matter the order of it. So you can write x minus 3 first, or you can write x plus 7 first. It gives you the same result if you were to FOIL it. So let's check if our answer is correct. So if we were to rewrite this answer, x plus 7 times x minus 3, we can use the FOIL method to expand these two binomial terms. So if we multiply x times x, that's this is our outer, x times negative 3. Our inner is 7 times x, and our last is 7 times negative 3. So if we multiply, x times x gets us x squared. X times negative 3 is negative 3x. X times 7 times x is 7x. And 7 times negative 3 is negative 21. So if we combine like terms, we get x squared plus 4x minus 21, which is exactly what our original answer was. So you can always check if you factored correctly or not. Alright, so another one. Which of the following is an equivalent to 8x squared minus 22x plus 15? So for this one, we can try the other method, which is basically like guessing and checking. But the thing about this particular quadratic is that if you were to try to factor it, you would have two possible, let's call them sets. One of them, you would have 8x and x, because 8x times x gets us 8x squared, but also you would have 4x and 2x, because that would also get you 8x squared. So we don't want to just sit there and try to do guessing and checking. So there's a more straightforward method that we can use, which is called the AC method. So as before, as a reminder, the standard form of a quadratic equation is always ax squared plus bx plus c. The AC method basically states that we take our a and our c term, we multiply them together, and we find factors of that and we replace it. So first we have to see what is our a. Our a is our first term, which is 8 in this case, and our c is 15, which is our last term. So we take them and we multiply. So 8 times 15 gets us 120. And then we need to find factors of 120 that add up to get you that middle number, negative 22. So the only way for that to happen is 10 and 12. And they need to add up to get you negative 22, so they need to both be negative. Okay, so now what we do is we replace. We replace that middle term, negative 22x, with the two numbers we just found. So you have 8x squared minus 10x minus 12x plus 15. So we haven't changed the nature of our quadratic yet. All we did is replace the middle. Now what we do is we group up first two terms and the second two terms, and we find the greatest common factor between each parentheses. So for the first one, we can pull out a 2x. That's the greatest common factor between the first parentheses, and what's left would be 4x minus 5. And the second set of parentheses, we have a negative 12x plus 15, so the common factor would be a negative 3. And again, we should be left with 4x minus 5. So when you do this process, you should notice that these two are the same, two parentheses. Because they're the same, you can pull it out as 4x minus 5, and you'll notice that the remainder here are 2x and negative 3, and we just put that together. 2x minus 3. So the factor form of 8x squared minus 22x plus 15, using the AC method, is 4x minus 5 times 2x minus 3. And again, the order of it doesn't matter, and you can always check by foiling to see if you get the original quadratic. Alright, another one, factoring completely, w squared minus 144. So when we look at this initially, we might not think it is a quadratic, but it in fact is a quadratic because we have a power of 2. As long as we have the greatest power is power of 2, that makes it a quadratic equation. Now how about we write it in a form we're more familiar with? So think about ax squared plus bx plus c. Let's write this as w squared plus 0w minus 144, because 0 times w still gets you 0, and you're left with just w squared minus 144. Now looking at this, let's use the AC method. So our a would be the coefficient in front of the w, which is 1. W squared, I'm sorry. C would be negative 144. Now we multiply them. Gets you negative 144. Now we find factors of negative 144 that add up to get you 0. Only way that can happen is you have 12 and 12, and they need to be opposite signs to get you 0. So one positive, one negative. So now we replace. W squared stays the same, but we write the middle as 12w minus 12w minus 144. And then we group up the first two terms, the second two terms. We find the greatest common factor of the first parentheses, where that would be w. And this would be w plus 12 left. And the second set of parentheses, we can pull out negative 12 because we have a negative in front. And we're left with, again, w plus 12. So we're left with w plus 12 in common in the parentheses, and our common factor, or sorry, our remaining would be w minus 12. So the factor form of w squared minus 144 is w plus 12 and w minus 12, which is answer choice C. Now this is a very specific quadratic equation, which is called a difference of squares. So a difference of squares is when you have a squared minus b squared, you can automatically factor that into a plus b, a minus b. And this only applies if you have two terms that are both squared and there's a minus in between. So let's apply that for this question. 36x squared minus 49y squared. So because it's already in squared form, we can apply some of the difference of squares. And also we don't want to try to do like the AC method or guessing and checking because the numbers are so big. So reminding, we can write our a squared minus b squared can always be factored into a plus b, a minus b. So let's keep that in mind when we're doing this. So if we correlate our difference of squares with the equation we have, we would have a squared, which is 36x squared, and b squared, which is 49y squared. So now we need to think about what would a be and what would b be. think about is you think about what will you square to get you 36. The number you square to get 36 would be 6. And in order to get x squared, you have to square x. Same thing for b. 49 would be 7 squared, and y is y squared. So now that we know that, we can put everything together. This is equivalent to saying a plus b, 6x plus 7y, and a minus b, 6x minus 7y. And that would be the factor form. And again, you can always check by foiling to get you it should get you the original answer. 6x minus 7y times 6x plus 7y. Okay, now we're moving on to actually solving quadratic equations. So in the last couple questions, we've only been factoring. The reason we factor is because whenever you want to solve for a quadratic equation, you need to factor it first. Set it equals 0 and factor it. So that's what we want to do with this one. So x plus 9 squared can be written as x plus 9 times x plus 9. I'm going to go ahead and write that 36 down there. Go 0. So we can FOIL x plus 9 times x plus 9. And that should give us x squared plus 9x plus 9x plus 81 minus 36 equals 0. So now what we want to do is we want to combine like terms. So we can combine the 9x's, it gets you 18x. And 81 minus 36 gets us 45. So now that we have our quadratic equation on the left and it's equal to 0, we can now factor. So just like before, we do the first guessing and checking method because it's a more simple quadratic equation. Think of two numbers that multiply gets you 45, that add up gets you 18. So you can always list them out, but we know 45 is 15 and 3, and everything will be positive, which makes it everything positive here. So now what we do is, now that it's factored, we set them both separately equal to 0 and solve for x. Subtract 3, negative 3, that's one answer. And minus 15 is 15. X equals to negative 15. That would be the answer. So our answer would be x equals negative 3 and negative 15, or you can write this as solution set negative 3 comma negative 15, or either or. So his choice is B, negative 15 comma negative 3. Okay, let's do another one. Solve the equation 3x plus 6 over 3 minus 4x over x minus 3 equals to x. So now we're involving an equation that has fractions. So first thing we do when we deal with any equation following fractions is we need to find an LCD, the least common denominator. And the best way to find LCD with these is just multiply the two denominators we have right there. So it should be 3 times x minus 3. So we take our whole equation, and now we take that and we multiply by the LCD. So now we take the 3 times x minus 3, distribute it to everything on the inside of our parentheses. This is going to look like 3x minus 3 times 3x plus 6 over 3 minus 3x minus 3 times 4x minus 3 equals to 3 times x minus 3 times x. Okay, so before we try to multiply this, see if we can cancel. We see that we can cancel a 3 on top here and a 3 on bottom here. And an x minus 3 on top, x minus 3 on bottom. So we can now write this as x minus 3, 3x plus 6, minus 3 times 4x equals to, I'm going to write the 3 and bring the x from the right all over here next to it, x minus 3. So now we have no more fractions to work with. So what we did is we used the LCD to clear the fraction. So now we can simply just expand these. So we can expand the first one by foiling. We would get 3x squared plus 6x minus 9x minus 18. Negative 3 times 4x is negative 12x. Over here on the right, we distribute the 3x into everything. 3x squared minus 9x. Okay, so we want to combine like terms. We have 3x squared. 6x minus 9x is negative 3x. Minus 12x gets us negative 15x. Minus 18 equals a 3x squared minus 9x. So when you're solving for a quadratic, again, you want to bring everything over to one side and make it equal to 0. So let's bring these and bring them over to the left side. And then we can add 9x. So we notice that these cancel, but also the 3x on the left, 3x squared on the left also cancels. So we have negative 15 plus 9 is negative 6 minus 18 equals 0. So now it's just a linear equation. We can add 18 both sides. So it's negative 6x equals to 18, and we divide by negative 6. So x would be equal to negative 3. And that will be our answer choice. So we went from having fractions to clearing the fraction to having quadratic. In this case, coincidentally, our quadratic goes away because our x squareds go away, and we're left with just a simple linear equation. So the answer is negative 3. Alright, so using square root property, if square root of w plus 3 equals to w minus 3, then w is equal to what? So whenever you want to solve for a square root equation that involves a square root, first thing you want to do is you want to get the square root by itself. So in our case, our square root is already by itself. And after that, what you want to do is you want to get rid of that square root. So you want to get rid of a square root by doing the opposite of it. The opposite of square root is a square. So if you were to square both sides, because what you do on one side, you got to do to the other. On the left side, we're left with just w plus 3, because the square and the square root cancel each other out. And then w minus 3 squared is the same thing as saying w minus 3 times w minus 3. So we would have to FOIL that. So we have w squared minus 3w minus another 3w plus 9. And combine like terms. Minus 6w plus 9. So now, dealing with the quadratic, we want to bring everything over to one side. So because we have more things on the right than we do on the left, let's bring the stuff on the left over. So we can subtract w, put it right under there, and go ahead and subtract 3 as well. So this goes away, this goes away. We're left with just w squared minus 6w minus w is minus 7w, and 9 minus 3 is positive 6 equals 0. So now we want to factor. So we want to find two factors that multiply get you 6, but add to get you negative 7. Only factors of 6 that get you 7 would be 6 and 1. And they need to multiply get you positive and add to get you negative. That means they both need to be negative. So we set them separately. Equals 0. So if you add 6 over, you get w equals to 6. And then if you add 1 over, you get w equals to 1. So normally, if our equation was just that would be the answer, right? But we're dealing with the square root, so we have to understand its properties. So when you're talking about a square root equation, you always have to check, because in math, whenever you take a square root of something, you can't get a negative out of it, technically. So we need to check if we were to take our two answers, 6 and 1, and plug it into our original equation, will it make sense? So we check this. Let w equals to 6. So we would have square root 6 plus 3, because we plug it in wherever we have a w, and we're checking, is that equal to 6 minus 3? So 6 plus 3 is 9. 6 minus 3 on the right is 3, and the square root of 9 is 3. So that would be correct. Now what about 1 though? Let's check it. Square root 1 plus 3, is that equal to 1 minus 3? So square root of 1 plus 3, 1 plus 3 is 4, and 1 minus 3 though, that's negative 2. Square root of 4 though is 2, which is not equal to negative 2. Right, so that's false. So it tells us the only answer would have to be w equals 6. So whenever you're solving an equation that involves square roots, you always want to plug it back in and check if whatever answers you have make sense in the equation. So the only answer is 6. So you see that A is a viable option as well because it gives you the two answers you solve for. But because you have to understand the square root property, you always got to plug in and check. The real answer would actually be C, just 6. Okay, completing the square, solve the equation. So sometimes there are some instances where we can't factor a quadratic equation. This is where completing the square comes in. So let's look at that. So basically completing the square, let's take this into account again, our standard form of our quadratic equation. Completing the square basically states is that if we can't factor it, what we do is we take our b value, we divide it by 2 and we square it, and we add to both sides of our equation. So let's say for instance we can't factor this. First thing we need to do is, to make it easier for ourselves, let's subtract 3 both sides to bring that 3 by itself on the right. 4h equals negative 3. So now we take our b value. Our b in this case would be negative 4. We take that and we divide it by 2 and we square it. So negative 4 divided by 2 is negative 2. Squared equals to 4. We take that 4 and now we add to both sides of our equation. So we have h squared minus 4h plus 4 equals to negative 3 plus 4. So we have to add it because we need to add it on the left side. And what we do on the left side of an equation, we have to also do on the right. Now that we've completed the square, now that we've done that, we can now complete the square by factoring. So you look on the left here, you can factor h squared minus 4h plus 4. You think of two numbers that multiply to get you positive 4, but add up to get you negative 4. So they would have to be both negative 2. And on the right, negative 3 plus 4 is just positive 1. And h minus 2 times h minus 2, another way to write that, is h minus 2 squared equal to 1. So this right here on the left is what's called a perfect square. Whenever you complete the square, you should be getting something called a perfect square. Now to solve this, just like the last one before, you want to get rid of the square. To get rid of the square, the best thing to do is the opposite of it, which is the square root. Because squares always cancel each other out. What you do on one side, you gotta do to the other. Square root both sides. So left here, the square and square root cancel. H minus 2. And the square root of 1 is 1, but it's not just 1, it's also plus or minus 1. Because square root is the opposite of a square. 1 squared gets you 1. But also negative 1 squared can also get you positive 1. Because negative 1 times negative 1 is positive 1. So we have two answers here. Let's go over here. H minus 2 equals a positive 1. And h minus 2 equals negative 1. So solve them. Add 2, add 2. Do the same thing over here. So h is equal to 3. And h is equal to 1. So those would be our answers. So, or we can write this as 3, 1 as our solution set. 3. Alright, let's do another one. Completing the square. Now, sometimes some quadratic equations, they don't always tell you to complete the square. So before you try to complete the square, you can always check if you can try to factor this equation normally. So just like the normal guessing checking method, we would do y here. We have to think of two numbers and multiply each to negative 2 but also add up to negative 2. Now this wouldn't work though, because the only factors of 2 are 1 and 2. And there's no way for 1 and 2 to add up to get you negative 2 in the middle there. So that means that we can't factor it normally just yet. So we have to complete the square for this one. So first thing we do is we add 2 both sides. Goes to 2. We want to identify what our b is. Our b is a negative 2. So it's right here on the green. Let's say b is negative 2. So we take that negative 2, we divide it by 2, and we square it. So negative 2 divided by 2 is negative 1. Squared gets us a positive 1. So now we take that positive 1 and we add to both sides of our equation. So we have y squared minus 2y plus 1 equals to 2 plus 1. Okay. Now doing that, we can now factor the left side, because we think of two numbers that multiply, that gets you 1, but also adds up to get you negative 2. That would have to be a negative 1, negative 1. And on the right side, 2 plus 1 is 3. And then we can write y minus 1 times y minus 1 as y minus 1 squared. So now, just like before, we can take a square root to get rid of it. And what we do on one side, we got to do to the other. So left side here, square and square root cancel. Y minus 1. Right side, we can't take a square root of 3, but because we keep it under the square root, but because we technically took a square root of it, we always need to have plus or minus. So the last thing we can do now is just add 1 both sides. So our answer would just be y equals to 1 plus or minus root 3. So you can write it as 2 separate terms or 1 term. Either or would be fine. But you always want to check what the answer says on your TSI question. So if you notice, it's written in plus or minus form. So the answer would be B. Right, so another one, solve the equation. But this time, you notice what's different from the other two is that the coefficient in front is a 2, not just a 1. So when you're doing complete the square, you need to make sure that the term in front here has to be 1. So when you're talking about like that, your A term has to be 1 in order for you to complete the square. If it's not, you got to make it 1. So for this case, in order to make it 1, we divide everything by 2, because we got to do it to everything. So that gives us x squared plus 1/2 x equals to 5. So again, we want to identify what our b term is. Our b term in this case is 1/2. So we take 1/2, we divide it by 2, and then we square it. So 1/2 divided by 2, it's like saying 1/2 and you flip the 2 as another 1/2. 1/2 times 1/2, and you get 1/4. And if you were to square it, you square top and bottom, you get 1/16. So we take that 1/16 and we add it to both sides. Okay, on the right side, 5 plus 1/16. Okay, so now we're going to factor. Now, because this time we're dealing with fractions a little bit harder, but we know for sure it's going to be a perfect square, as evidence on the last couple questions we're doing. Every time you do complete the square, you're going to get a perfect square. So you're going to have x here, something squared. Now what goes here is the trick is you always want to make sure you write everything over here on the left. So what goes here actually is what happens in the parentheses right here. 1/4. And then because everything's positive, you would have positive everything here. So that's why you always want to make sure you want to write everything out. And the reason is because 1/4 times 1/4, because we need to find two numbers that multiply to 1/16, and we need to add up to get you 1/2. So 1/4 times 1/4 gets you 1/16, and then 1/4 plus 1/4 gets you 2/4, which reduces to 1/2. So it is a kind of like a little shortcut. Is if you write this out, you know that whatever goes here is going to be what you squared earlier. And on the right side, 5 plus 1/16, think of it as 5/1 times 16 times 16. That would be 80/16 plus 1/16 gets you 81/16. So that would be on the right side. So now we take a square root both sides to get rid of the square. So square and square root cancel. We got x plus 1/4. Now we can take a square root of 81/16 because square root of 81 is 9 and 16 is 4, but we need plus or minus. So we have two answers here. We have x plus 1/4 is positive 9/4, and x plus 1/4 equals negative 9/4. Subtract 1/4 both sides. So we left with 9/4 minus 1/4 is 8/4. Left with 2. That's one answer. And then negative 9/4 minus 1/4 is negative 10/4. Oh, let's do it like this. Which can then be reduced as negative 5/2. So our solution set can be written as negative 5/2, comma 2. Right? So the answer choice is C. So working with parabolas, given f of x equals x squared minus 4x plus 3, find the minimum of the quadratic equation. So, like any equation, you can always graph it. The graph of a quadratic equation is what's called a parabola, and that basically looks like this is our x and y graph, something like this. So basically a U shape. That's if it's a positive, if a is positive, and if a is negative, it would actually go down, right? So if you notice, there's always, if it's our a is positive, there's always something what's called a minimum point. The smallest value, it would be that very dot right there. Same thing for if it's a negative, it'd be right there. That dot right there, that point, is actually what's called the vertex. And the vertex can be minimum or maximum depending on what type of quadratic equation you have. So these are called the vertex. Let me write that out. In this case, this would be the max, and then this would be the min, because lowest point, highest point. Okay, so knowing that, we can actually find the vertex very easily. To find the vertex of a quadratic equation, there's a little formula to find, because we're talking about point, we need an x and a y point. To find the x point of that, and the x value, you're basically do negative b over 2a. And again, that a and b comes from the standard form of our quadratic equation, ax squared plus bx plus c. So in our case, negative b would be a negative 4 over 2a. So 2 times 1, because our a is 1. So if we simplify that, we get negative is a positive 4 over 2, gives us 2. So the x value of our vertex is 2. Now we also need to find the y value, because we're talking about points. To find that, we just take our 2 and plug into our function here. So y be f of 2, which is 2 squared minus 4 times 2 plus 3. So 4 minus 8 plus 3. 4 minus 8 gives us negative 4 plus 3. So that's negative 1. So our y value is negative 1. So our vertex slash minimum, because that's what our, in this case it's called, would be the point 2 comma negative 1. It's choice A. Alright, so another quadratic equation, but this time it's written in a different form. So this time it's written in the form where this is actually what's called the vertex form. Because if you know the vertex form of a quadratic equation, it's always f of x equals to x minus h squared plus k, where h and k are considered your vertex. So, because it's written in this form already, all we need to do is identify what's our h and what's our k. There's no need to do any other math. So in this case, our vertex would be the h value, which is the inside the parentheses, that's 2, and the k would be the outside, which is 3. Now, because the reason it's just 2 and not negative 2 is because by default, our equation here has a negative h. So that means if you see a negative 2, you assume the h is just 2, not negative 2. So our vertex is just 2 comma 3. Answer choice D. Alright, so the last thing we do today is the line of symmetry. Find the line of symmetry for the figure. So when we're talking about line of symmetry, think about a line that you take and you cut it straight down, or whatever side you do, and it gives you a mirrored look. That means the left and the right side, or top and bottom, whatever it is, looks the same. So if we look at our answer choices here, we see, let's go through them, right? HD. If we take HD and we cut it right here, it doesn't get you symmetrical, because if you try to fold it, it wouldn't be the same both sides. What about AF? AF, we cut it straight down. That could work, right? If you fold it across the AF, that would look good. Let's try the other ones. BH. Nope, same problem, right? Same thing for JD. That also wouldn't work, right? So the only reasonable answer in our answer choices would be AF.